On May 19, 2026, Starship V3 will attempt 5 fully autonomous maneuvers in space that no rocket in history has ever executed, and every single one of them must work, or NASA loses its only path back to the moon. Most coverage of this flight talks about height records, engine counts, raw spectacle, but the numbers are not the story. The story is what happens after Starship V3 clears the atmosphere, because the 5 systems activating above the atmosphere are the exact same systems that must protect human lives on the Artemis 3 lunar landing. This is not a test flight, it is the audition. In the next 12 minutes, you will find out what those 5 systems are, why they have never been attempted before, and why the entire future of American spaceflight is riding on a rocket with no pilot, no abort button, and no way to call Houston if something goes wrong. SpaceX loaded 5,000 metric tons of propellant, 11 million pounds, into this vehicle for a single countdown rehearsal. That number alone tells you how serious this is. But here is the question that nobody in mainstream coverage is asking. Each of these 5 autonomous systems carries a specific failure mode. You know, one of those failure modes, if triggered on the actual Artemis 3 mission, would leave 4 astronauts stranded in lunar orbit with no way home. Which system is it? And has SpaceX actually solved it? That is what this video is about. To understand what Flight 12 actually is, you need to understand what Starship V3 is not. It is not an upgrade. SpaceX President Gwynne Shotwell described V3 in early 2026 as a ground-up reevaluation of every major system on the vehicle. That is not marketing language. It means engineers went back to first principles on propulsion, structures, flight software, and thermal protection and rebuilt the entire stack from scratch. The result is the tallest structure ever launched from Earth. For the 3rd time in 3 years, SpaceX has set that record. V3 clears the previous variant by several meters. The Super Heavy booster alone generates more thrust than any rocket in history. More than the Saturn V that carried Neil Armstrong to the moon in 1969, more than the Soviet N-1 that exploded 4 times and never reached orbit. But Elon Musk has said repeatedly that raw power is the easy part. Power is physics. You can calculate power on a whiteboard. What you cannot fully simulate on the ground is autonomous decision-making in the vacuum of space. And that is the problem Starship V3 was built to solve. Here is what NASA's Artemis 3 mission actually requires. After launch, after reaching orbit, after the crew transfers from the Orion capsule, the Starship human landing system must autonomously navigate to a point above the lunar South Pole, precisely manage its own propellant reserves, inspect its own thermal tiles for damage, and deploy its landing legs on a surface that has never been mapped at the resolution needed for a precision touchdown. Every one of those actions is autonomous, not automated, autonomous. There is a critical difference. Automated means the computer executes a pre-written script. Autonomous means the computer reads the environment, makes a real-time decision, and adapts. On a vehicle this size in the environment of deep space, nobody has done this before. Not SpaceX, not NASA, not Russia, not China, not anyone. Flight 12 is where they try. And this is the part that almost nobody in the media is covering. If this level of technical detail is what you want from space coverage, subscribe before we get to the 5 systems. The next part is where it gets genuinely unprecedented. Let's go through all 5. Autonomous system number 1 is the self-inspection array. Space.com broke this story 10 days before launch. Starship V3 will, for the first time in the program's history, use an onboard camera array to visually inspect itself while in orbit. The vehicle will autonomously identify tile damage, structural anomalies, or sensor failures, and transmit a real-time damage map to mission control before any re-entry decision is made. Why does this matter? In February 2003, NASA DID have foam strike data from Columbia's launch. What they did not have was an autonomous system capable of translating that data into a visual damage assessment in real time. 7 astronauts died. The self-inspection array on Starship V3 is a direct engineering response to that failure. 23 years later, whether it works in orbit, at full temperature differentials, well, the vehicle rotates. That is what Flight 12 will answer. Autonomous system number 2 is cryogenic propellant transfer. This one is make or break for Artemis. Here is the problem. Starship cannot carry enough propellant from Earth to land on the moon and return. The physics do not work. So NASA's plan, the plan that Administrator Bill Nelson signed off on and Congress funded, requires a separate Starship tanker to launch, rendezvous with the lunar Starship in orbit, and transfer hundreds of tons of liquid oxygen and liquid methane from one vehicle to the other, in zero gravity, autonomously. This has never been done at scale. Russia attempted a version during the Mir era and abandoned the program. NASA studied propellant transfer for the space shuttle architecture and determined the risk was too high. SpaceX says they have solved it. Flight 12 will demonstrate a scaled version of the transfer protocol, not a full tanker rendezvous, but the internal propellant management logic that makes autonomous transfer possible. If the header tank sequencing fails on this flight, the Artemis timeline slips by at least 2 years. Think about that. A failure in a software sequence over the Gulf of Mexico could add 2 years to the date humans return to the moon. That is the weight this vehicle is carrying. Autonomous System Number 3 is precision attitude control during coast phase. Previous Starship variants had documented instability here. Flights 10 and 11 showed the vehicle drifting outside its planned attitude envelope during coast, causing complications with the re-entry burn. An anomaly in the attitude control data from those flights went almost entirely unreported while the world was focused on booster catches and spectacle. V3 introduces an upgraded cold gas thruster array and a new flight control algorithm designed to hold attitude within a fraction of a degree for the full duration of coast. If it works, Starship V3 becomes genuinely capable of the long-duration deep space missions the moon landing requires. If it doesn't, they have a very large, very expensive weather vane. Autonomous System Number 4 is the Embedded Heat Shield Monitoring Network. V3 introduced a new sensor grid woven directly into the thermal protection tiles. During re-entry, these sensors measure tile surface temperature in real time and feed data to an onboard algorithm that can autonomously adjust the vehicle's angle of attack, its orientation during hypersonic descent, to protect areas showing elevated thermal stress. The space shuttle had no such system. Orion has limited thermal sensors but no autonomous adjustment capability. This is new engineering territory entirely. Elon Musk posted specifically that the new tile sensor network was the achievement he was most proud of on V3. That is a pointed, specific claim from a founder who has a long list of things to be proud of. Flight 12 will either validate it or expose it. If that changed how you understand what Starship V3 is actually attempting, subscribe now. And here's the preview. The 5th autonomous system is the one that connects directly to human survival. And it has a failure mode that NASA's own engineers have flagged in internal reviews. That answer is 60 seconds away. Autonomous System Number 5 is precision landing with terrain relative navigation. On the moon, there are no GPS satellites, no radio beacons, no infrastructure of any kind. When Starship HLS descends toward the lunar South Pole for the Artemis 3 landing, it will use a combination of LiDAR, optical cameras, and a preloaded terrain map generated from orbital survey data to identify a safe landing zone in real time, autonomously, with 4 human beings aboard. This technology is called terrain relative navigation. NASA used a version of it on Mars. Perseverance used TRN to land in Jezero crater in 2021. But a rover weighing 1 ton landing at a few meters per second is fundamentally different from a vehicle the size of a 20-story building, carrying crew, touching down at the lunar South Pole, a region of permanent shadow, unknown surface composition at depth, and crater density that makes precise terrain mapping extremely difficult. Flight 12 will not attempt a lunar TRN sequence, but it will test the sensor fusion architecture that underlies the lunar version, the LiDAR array, the optical flow algorithms, the terrain map matching logic. If these systems perform within specification on Flight 12, SpaceX can begin the high-fidelity lunar terrain simulations that must be completed before Artemis 3 is cleared for crew. Now here is the answer to the question we opened with. The failure mode that NASA's internal engineering reviews have flagged, the one that could leave astronauts stranded in lunar orbit, is in System 5, specifically in the terrain map matching algorithm. If the lunar surface in the target landing zone differs from the preloaded map by more than a defined threshold, due to a recent micrometeorite impact, an unmapped shadow gradient, or surface composition variations, but without a human in the loop, it must either abort autonomously or attempt to locate an alternative zone. The autonomous abort protocol for this exact scenario has never been tested at scale. SpaceX's engineers know this. NASA's engineers know this. And Flight 12, while it will not replicate this scenario, will generate the sensor data and algorithm performance logs they need to refine that abort decision tree before it matters for real. That is why Flight 12 is not a milestone to be celebrated. It is a stress test of systems that will someday carry people. Gwynne Shotwell said it best at the 2025 International Astronautical Congress. Every Starship flight teaches us something we could not have learned on the ground. Flight 12 will teach us more than any before it. She was not talking about the height record. She was not talking about the booster catch. She was talking about what happens in space when the vehicle is alone, when the systems are running, and when nobody is watching. That is the real story of Flight 12. That is what Starship V3's 5 autonomous systems actually are, and why each one carries weight that goes far beyond this single test flight. But here is the question nobody thought to ask next. Once Starship lands on the moon with astronauts aboard, how do they get back? The return trip requires a completely separate autonomous docking with Orion in lunar orbit, zero margin for error, and no rescue option if it fails. We break down exactly how that works in our next video, how NASA's Artemis 3 moon mission actually works, and why it's harder than Apollo. Link is on screen now. Subscribe so you do not miss the one after that.